Now, there are two types of quantitative data, discrete and continuous. So the first we're going to look at is called discrete, continuous data. And what makes continuous data discrete is it's all data that is a result of counting. So if you select a particular datum from a discrete data set, there is a next data value. So some examples would be body temperature measured with a digital thermometer, an odometer on your car, and family size. That's an example of a count. And so you could have a family size of 2, family size of 5, family size of 1 and 7, etc. I think it might be better to maybe understand discrete by contrasting it with continuous. So you could have continuous quantitative data. I need to change. This should have been discrete. Quantitative data. Okay, so under continuous quantitative data, this is all data that's recorded as a result of measuring. So if you select a particular datum from continuous data, there is no next data value. So let's look at this difference first between body temperature. So, body temperature is a measurement, and that's why it counts as quantitative data. But look at the difference. If you measure it with a digital thermometer versus if you measure it with a glass thermometer. Now, a digital thermometer is going to have a limit of maybe measuring to 1/10 of a degree. So 99.1 or 97.6 or 98.1. So if you had a measurement of 98.1 on our digital thermometer, then the next data value we know is 98.2. It's not going to be anything between 98.1 or 98.2. But if you look at a glass thermometer with like mercury or I believe it's like a red alcohol solution on the inside, it's a glass tube and it's got markings on the edges. Something like that. And you tell the temperature by looking about how far that liquid on the inside has traveled up the thermometer. And so, where this stops could actually be somewhere between 98.1 and 98.2. But because the liquid inside the thermometer stopped somewhere in between those two, you don't really know by looking at this measurement scale whether it was 98.15 or 98.1562 or 98.1563 and so on. So this glass thermometer, this kind of like analog thermometer, doesn't measure as accurately. So therefore, there is no next data in between 98.1 and 98.2. There's an infinite number of decimal points of accuracy between those two. So, this would be an example of a continuous quantitative data, whereas using a digital thermometer, because it can only be these discrete values and nothing in between, that's what makes a digital thermometer discrete. And so again, like if you're to draw blood using a syringe that had markings with milliliters, even though maybe you pulled on the syringe and you were able to extract 40 milliliters of blood or 25 milliliters of blood. Again, you're kind of running into the same problem, where you've got your syringe and maybe that's 40 milliliters, 30 milliliters, and 20. That stopper may not stop at exactly 40, depending on how you pulled it. That stopper could be somewhere right there. So it's not going to be exactly 40. It could be 40.013, 40.0132119, and so on. So because there isn't, a next data value that you could actually stop at using this syringe, that's what makes this an example of continuous quantitative data.